we are running the Mission Impossible lab. And for this particular lab, we are running 4 solids, 3 metals, and 1 ionic compound, calcium carbonate, against 5 different solutions. We have 3 acids, 2 of them are strong, hydrochloric acid, sulfuric acid. Those both are strong, and which means they completely dissociate in solution. And then we have 1 weak acid, which is acetic acid. So just to remember, weak acids, they are acids, they do donate a hydrogen in solution, but because they are weak, which means they don't dissociate well. So it will donate a hydrogen, but when we see this in solution, the vast majority of it is left undissociated. So what you see is what it is in solution. And then the other ones we have are sodium carbonate, another ionic solution. It's a basic solution, so it does dissociate in water very, very well. Group 1s typically do. They do. And then copper sulfate, copper 2 sulfate. And this is kind of like a bluish solution. So what I'm asking you to do in this particular lab is to cross these solids against these aqueous solutions and see what kind of reactions we would get. If nothing were to happen, you would simply write as far as a reaction, for example, magnesium against hydrochloric acid, you would put those in solution, and ultimately I would be looking for a net ionic solution, which means the stuff that's actually doing something. And then you writing what would be the potential products in that reaction. So the way you would kind of go about this lab is what I would probably do, and I'm going to show it to you right now, is I would display something like this, or you would actually create this, in which you would set up like a table, and then you kind of put these into like spot plates, and then you run the reaction. For example, magnesium against all of the solutions. So this is magnesium metal in all of these little spot plates, and then I'm going to add some solution to all of them to see how magnesium reacts with these. And then I would do the same with the iron, and the iron I actually use a powdered, pulverized version, so it has more surface area, so you can see the reaction more effectively. And I did the same with the zinc, and then the calcium carbonate. Calcium carbonate would be like marble chips, but again, this is pulverized out, so it's just a powdered form of it, and then I'd run these against each other. After we run through this part, what I would like to do is then just run the 5 solutions against each other and see what kind of reactions you get out of those as well. So I'll set up a couple of these, and then I'll pause and put the other ones together. So the first one I'll take a look at here is the sodium carbonate, and I had loaded up this barrel pipette with the sodium carbonate. And then I'm going to put that into the bins for this row here and look for reaction. Now some of these are pretty quick, and some of them are not so quick. So the idea is to kind of get them saturated and then look for a reaction. So I'm not going to pause and look for that right now, but at least I'm just going to get them kind of set up. This is the acetic acid. So again, in the barrel pipette, it's kind of clear. Just kind of let them do their thing. I can already see something going on with that one really quick. This is the hydrochloric acid. No messing around there. This is the sulfuric acid. Pretty exciting. Don't think I want to get that on my skin. And this is the copper 2 sulfate. You're not getting the stink on your end that I am, but some of these smell pretty awful. I'm going to add a little bit more to some of these guys just to kind of get their effect going. So you watching this, and we're kind of getting all the effect that we need out of these to see what's doing what. And I can help along as far as how these are behaving too. Clearly, that's a reaction, that's a reaction. And it's what is the evidence that we're seeing with these reactions? If you see like a physical change, which I definitely see here, you have this kind of like crusty stuff kind of forming on there. That's a reaction going on. And I can see that throughout some of these blue ones. And also, the fact that you're putting a blue solution in here and then the blue solution is kind of gone, that's a change. And I'll add some more in here just so we can see that maybe a little bit better. So again, it may take some time going through there. But notice the stuff remaining is kind of more reddish in color, copper sulfate. This one's kind of turned more like a blackish. But it was kind of more like, you know, this silver-ish color. It's zinc, but the color we kind of refer to. So definitely some type of a reaction going on there. And this one is a little bit harder to see. It's still whitish, still kind of bluish, but there's something kind of going on here. And I realize I'm kind of cross-contaminating because I keep using the same toothpick going across here, but generally that's kind of okay. I will change that out. And so we can kind of see again with these bubbles, that is an indication of a chemical reaction taking place. These color changes, the switch you're seeing, that was a blue solution put in here, and for the most part you don't see that blue solution. Bubbles aren't all the same. So the bubbles you're seeing forming up here may be different than the bubbles you're seeing down in these spot plates. So we have to kind of decide what is a reaction and what is not a reaction. Notice I've kind of been ignoring this side over here. I don't really see many bubbles or anything actually going on over here. Something similar over here, I don't really see much of anything happening. I would agree with the same thing over here. And here it's kind of nothing really happening. But I am seeing some pretty significant reactions in the other spot plates. Maybe some more than others. Obviously, I'm very much seeing over here. These guys, upon first like glimpse, like this one, I clearly see something going on. Bubbles. I see bubbles. Hang on here. This one, I'm not really seeing the bubbles as well, but if you were to sit here long enough, you would see enough significant bubbles. And I would say the same thing going on here. And even here. This one you can see the bubbles kind of forming there. But the other ones are a little more blah. I don't see them as quickly. The other ones are more significant. But again, notice who you're dealing with here. It is an acid, acetic acid, but it is a little bit more of a weak acid. So it's not as exciting as hydrochloric and sulfuric acid were when they reacted with the metals. So they do the same thing, just not as significant. And I don't know if you could actually see this one. It looks like it might have been off camera when we were doing it, but I'll bring that up. The calcium carbonate down here. So this one again was kind of like they're all white powder, but as far as how they reacted was a bit different. These three, definitely you see a significant change. This one's just gone, so is this one. This one is on its way to being gone. And then this one over here, you did get kind of a different precipitate, taking on that bluish color within there. And again, I could probably get that bluish color to go away if I were to balance this out a little bit more with the calcium carbonate. But again, over here, I don't really see anything exciting happening. Okay, so I've kind of laid those out as far as reactions, non-reactions, and then eventually I'll come back over and show you on the board what I would be looking for. So on your sheet, what you should be doing is putting out something looks similar to this table here, and then putting in a reaction and what's your evidence. So bubbles, changing color, something along those lines, or dissolving, or you would just say NR, which indicates no reaction. So I have another spot plate set up I'm going to do here in just a second, which will show the solutions against each other.